Hey guys, so today we're going to look at processors and upgrading memory. These are two of the most common things that you can do to either update your PC or increase its capability. So let's go ahead and see what all is involved. Ooh, wrong one. Okay, so once again, we are updating and upgrading computers, and probably the easiest way is to look at processor and RAM. The objectives for this module: compare characteristics and features of Intel and AMD processors used for personal computers, select, install, and upgrade a processor, compare the different kinds of physical memory and how they work, and then upgrade a memory. Processor is installed on the motherboard, basically determines system power. There are two major manufacturers, Intel and AMD, and they are not interchangeable. Intel will not work with AMD and vice versa. Features affecting processor performance: that'd be speed, lithography, that's how the chips are written or how they are etched. Socket and chipset the processor can use. Now, just because you got a processor, you have to have a socket on the motherboard for it to go in, and they have different features. And also there are other chips. You got a north bus, a south bus, and a BIOS chip, and some other things that the processor also needs to work with. Multi-processing capabilities: you have multi-cores, you have multiple processors. Some computers actually have two or more physical chips. Multi-threading, which is you can have a single processor, but it allows multiple simultaneous actions. And dual processors are specific to two processors in a single case. You need to know the different features. You need to know these two categories. Basically, hybrid processors are focused on 64-bit. However, they can handle 32-bit. Also natively. 64-bit processors or x64 are specifically 64-bit, and the only way that they can handle 32-bit applications is by emulating or simulating a 32-bit processor. Quad-core processor: this is inside the chip body itself. You can have multiple cores. Basically, it allows you to carry on a lot of different tasks at one time, and then each one of the cores, if it's hyper-threaded, each one of these cores can have multiple threads, which means each core can carry on multiple activities. Intel is probably the most well-known chip manufacturer. Basically, these are for high-end computers. They tend to be more expensive than AMD. You know, the Pentium Core i series, Core i9s, Core i7s. These are high-end desktop and laptop. Core i5 is pretty much the average, and then Core i3 is entry level. The older Pentium processors and Atom processors and Celeron processors, these are all low-end, either low speed or low capacity chips. The Centrino processor, basically that means that the chipset, wireless network adapter, all those things are connected into a single chip body. It saves room on the motherboard, but it's also definitely not a high-end unit. This would be something like you're going to use a mini PC or a micro PC, something like that. Intel dominates the market for servers. Core i9, i7, and then Xenon, Xenon Phi, and Itanium. Those are the high-end server processors. AMD, on the other hand, more popular with gamers and hobbyists because you can get a really high-end, really fast processor a lot cheaper than you can from Intel. The main difference, if you're curious, between Intel and AMD is not the capacity or the speed or anything like that. What it is the quality control. AMD can have a lot of variation. If you buy a 3.2 gigahertz chip from AMD, it can have a lot of variation. It can be way below 3.2. It won't be too much above it, but it ranges generally down from there. On the other hand, if you buy 3.2 gigahertz from Intel, that's what you're going to get. Ryzen Pro, Threadrippers, these are common desktops, and then laptops. You have the A series and A series Pro, And then servers, you have EPYC and Opteron. You don't see a lot of AMD servers, though. Most of your servers are going to be Intel. This is what an AMD chip looks like. It installs in a 3+ processor. This is an 8-core chip. Probably you might find that in a server. You could probably use that for a server, but for the most part, that's going to be a gaming, high-end gaming chip. Hardware technician is sometimes called to assemble computers, to exchange faulty processors, to add a processor, or to upgrade an existing processor. The thing you have to do before you can do any of that is you got to know what motherboard and socket that you're working with, because that is what will dictate what you can add and what you can't. Selecting a processor, always look at the support. Look at the documentation, look at the internet. You've got to have a processor that motherboard is designed to work with, that the socket is designed to work with, otherwise it won't work and you'll spend a lot of money, generally someone else's money, for no reason. Also, in the end, you have to install it, and there's a thing called thermal compound or thermal paste that we'll talk about. Sometimes it's already installed on the processor, sometimes you have to apply it yourself. You need to be aware of what it looks like so that when it's time, you'll know if it's already installed or not, and you'll know how to install it. This is thermal paste, this gray square. This has already been installed at the factory on this cooling unit. So this is a fan that sits on top of the processor, and this gray paste basically is just a thin layer. And what it does, it conducts heat away from the processor chip a lot more efficiently than just sitting the copper metal on top of the chip and letting do it that way. So this is pre-applied. If you have to apply it, it comes in a little syringe looking package, and you squeeze out a blob onto the back of the chip where this would ordinarily rest, about the size of a small English pea. And then when you put the fan down on top of it and latch it in, it spreads it out like it needs to. Okay, once you install it, you absolutely, beyond all shadow of a doubt, anytime you're working inside a computer, this number one bullet point here is the absolute rule. Use a anti-static strap or anti-static gloves. Some shops have anti-static mats that you can stand on, but you absolutely need to make sure that you're grounded and that you're not going to destroy the processor or the chip that you're working with because your body has static electricity. Power down the system, unplug the power cord, press the button to drain the capacitors, and then open the case, remove the socket protective cover, open the socket by pushing down the lever and then raising the bars that hold the processor in place. When you do that, the socket load plate is raised up, and now you can remove the chip itself. Take the processor between your thumb and index finger, align it so that the key notches on the edge of the processor line up, and then very gently lay it down. Processors come with ZIF, or zero installation force, and basically what that means is you don't have to push at all. You just lay it on the socket, and it should, if it's lined up right, it'll sink right in. Otherwise, if there's some difficulty in getting that chip to go into the socket, don't push. You've got something lined up wrong, and you need to pick it up and look at it again before you press down on anything. Ensure the processor's aligned correct, and then once you've got it inside the socket, then you push the lever down and return it to its locked position. This is the lever that we're talking about here. This is the bar that holds the processor in place. So you put the processor down here, you close this, and then you close the lever, and it will latch. There's a latch on the other side that you should be able to clip this underneath, and it'll hold it down. And same thing here. Here are the notches, and there will be two corresponding notches in the chip. They act as a key, and so you can line those up with no problems, and it should just lay down on top of that socket and fit right in. Once you've got it installed, you'll close the bars, and then you'll close the lever. Once you've got it installed, you'll apply thermal compound if that's what's necessary. Like I said, it may be pre-applied. Look at the bottom of the fan or the cooler. If it's got a little gray kind of putty looking patch there, then you don't need to apply thermal paste. If it doesn't, then you need to apply one small dollop of thermal paste from the tube, like I said, a little round bit about the size of an English pea. Some heavy coolers provide a plate that fits underneath the motherboard because they are heavy and they will deflect or they will deform the motherboard. Install that plate if necessary, then put the cooler on top of the processor. If it just has locking pins, make sure that they're in the right holes and then turn them. Otherwise, push the little lever, or just depending on how the cooler clicks down onto the motherboard, and then connect the power cord that goes to the fan. If the cooler is air powered, there's going to be a fan on top of it, and there is a wire coming off the fan, and right around the edge of that chip socket somewhere you're going to see a little set of jumpers, and it'll usually say fan or something, or cooling or something like that. You plug the fan into the plug the cord from the fan into that jumper. Generally it will be keyed, so it'll only go in one way, and then boot the system up and check the BIOS to make sure that the processor is being recognized. So, like I said, about the size of an English P. That's the little dollop that you would install after you've got the chip installed in the socket. You've got the bar lowered, and you've got the clip that holds it in place locked. You put one little dollop of putty on there about the size of an English P, and then when you put the fan on top of it, now that, if it's a heavy processor, then you'll install this on the bottom of the board, and basically what it does, it reinforces the board because the fan in this case is really heavy, and it'll deflect and deform the board. So here's your processor. This goes on top of the chip, and then these 4 corner clips here, you'll clip those in. And then here is the fan power wire. You'll plug that into the jumper. That somewhere says fan or cooler on there. And at that point, the processor should be installed. Once you've got it plugged in, you'll boot up, and then your BIOS should recognize that there's a chip there. In this case, that was an Intel Core i5, and it recognized it. And you know that the fan's working because you can see that it has come on. Installing an AMD processor is basically the same thing. The chip may be shaped a little bit differently, the processor may be shaped a little differently, the socket may be shaped a little differently, but it's generally the exact same process. You've got the socket here, you've got the chip, you've got little blanks in here that have corresponding blanks on the socket, and so you'll line those up. Once you do, you have a lever here that locks it all into place. Then once you've installed the heat paste onto the top of the chip, you'll put the fan or the cooler or the heat sink, whatever, down on top and clip it into the socket just like that. And then once you've got that done, boot it up, make sure it works. Before replacing a processor, because it's generally an expensive and kind of time-consuming process, particularly for a laptop, it's a really annoying process because you have to disassemble the entire laptop pretty much completely. There's a lot of screws to unscrew and a lot of components to take off the board and a lot of fairly delicate pieces that you have to unscrew. And sometimes, especially if the laptop is under warranty, you don't want to do that, because if you do it, you'll violate the warranty. And because the motherboards are really specific to the processors that they use in laptops especially, it might just be cheaper to replace the whole laptop than it is to go out and buy a processor and go to all the time and trouble of installing it. If you do decide to do that, it's the same process. You just have to unscrew everything, take the entire system apart, and then change out the processor chip just like you would with a desktop. Put on the thermal paste. The cooler is going to look a lot different, but it's going to fit pretty much the same way. So here's the case. It's been taken apart. There's the processor fan. You'll notice the cooler looks very different. There's the heat sink, and basically what happens is this cooler brings in air from the vent, spins it around, and blows it over this heat sink. So this piece of copper here, this copper bar, is the heat sink, and then the chip is actually underneath this heat cooler here. So you'll unscrew that, you'll remove the heat sink, you'll remove the fan, you'll remove the copper bar, and then once you do that, you can lift it up. The chip will sit in this socket, and you'll take it out. And remember, when you put the chips in or take them out, you do it very delicately, because those pins are very delicate, and once you damage those pins, you've ruined the chip, and that can be $1,000 that you've just thrown away. All right, so let's look at memory. Random access memory, basically it's dynamic memory. That means it only temporarily holds data, and the minute you shut the power off, whatever information the RAM holds is gone. Dynamic RAM loses its data rapidly, and the memory controller has to refresh it thousands of times a second. Variation of dynamic RAM or DRAM. There are two types of chips packages that have been used in American computers. Currently in use is the DIMM, D-I-M-M, or dual inline memory module. That means it's got RAM chips on both sides of the chip, or on sides of the module. SODIMM is a single small outline DIMM. Basically, it's still a DIMM. It's not a single. It's a small outline DIMM. This is what you're going to see in laptops. Basically, they're very small chips, and they kind of fit in at an angle. So this is what a DIMM looks like generally for a gaming computer. They usually have really funky little heat sinks on them. This is a regular what you'd expect a DIMM to look like. Kingston RAM, usually this is pretty cheap stuff, but in this case it looks like it's pretty expensive. And then Dell 288 Dell DIMM, that's more DIMM. So basically these are examples of what DIMM packages can look like. Dual stands, or D stands for dual. It has independent pins on both sides, and so it has a 64-bit data path. SIMM, single inline memory module, is an old technology. Basically it had data modules only on one side of the package, and nobody uses SIMM anymore. DDR, DDR2, 3, and 4 are different speed levels, and they have different pins, and they are not generally compatible with each other. Factors that affect capacity for DIMMs: number of channels, usually 2. How much RAM is in one DIMM? You can have 8, 16, 64, 128, 256. 512 I'm pretty sure, but I don't know anything bigger than that. I guess you can have, gigabyte RAM chips. But at some point there's a limit. And then speed, whether it's DDR 2, 3, or 4. Error checking. ECC RAM generally is more expensive. Most people use that for servers. And then buffering, how much buffer is available, because buffering, basically your slowdown between your RAM and your computer processor is going to be the bus speed. And so buffering, basically a buffer holds a certain amount of information until it gets filled up, and then it sends it all in one spurt to the processor or wherever it's going, and then it starts filling up again. Okay, so you got 1, 2, 3, and 4 channels. Early single DIMMs, basically you can only access 1 at a time. Dual channels mean you can access 2 at a time. 3 channels, 3 at a time. 4 channels, so on. So DDR2, 3, and 4 DIMMs use dual channels. DDR3 can also use 3 channel, and DDR3 and 4 can also use quad channels. For dual, triple, and quad channels to work, the motherboard and the chip must support the technology, and the manufacturer usually color code the DIMM slots to show you how to configure dual, triple, or quad channeling. And you'll once again need to look at this, is all important, look at the motherboard documentation. Setting up dual channeling, they have to be matched. You can't use 2 different packages or 2 different manufacturers. They have to be matched in speed, size, and features. It says use the same manufacturer, and you really need to, because there are going to be small differences that can throw off it'll take away the advantage of using a dual channel. Setting up triples, 3 DIMM slots populated with 3 matching DDR DIMMs, so they need to match. This is kind of a schematic for a motherboard / processor. You got the processor here. You got a 64-bit bus. A bus is basically just a path that information travels on to the memory controller, and then you've got a bus for channel 2. That's the channel 2 for this would be a dual channel system. So you've got 2 slots for RAM, and they go through this 64-bit channel. That's channel number 2, and then you've got 2 more slots here, and this is channel number 1. And all of the channels are 64-bit. So these are what the slots look like on the motherboard. You've got these little side clips here. You open those all the way, or you shut them when you push the RAM in, and generally this RAM is registered with a key. It's got a slot somewhere or a notch in it, and it only fits in one way, so you don't have to worry about putting it in backwards. So you got two of them in the like this one and this one are one channel, this one and this one are two channels. So you got, this is a dual channel motherboard, and all four of these are identical. This would be DDR3 installed in a 3 channel system. So you've got basically 1, 2, 3. So you got 6 total sockets here. 1, 2, 3, 4, 5, 6. And this would be channel 1. This would be, pardon me, channel 1 would be these two. Channel 2 would be these two. And channel 3 would be these two. But as you can see, this slot down here is empty, this slot here is empty, and this slot here is empty. Oh, and then both of these slots are empty. You see this little white piece that's kicked back here? This is another one of these end pieces, these clips. And so you've got 2 channels up here that aren't being used at all, or 2 sockets rather. So this would be 3 identical DDR3s in a triple channel configuration. Expect a motherboard that uses quad channels to have 8 slots. So technically this one could have a quad channel. 1, 2, 3, 4. Each one has 2, so that would be 8. The 8 DIMM slots support 4 channels. Each channel has 2 slots, and the processor can address 4 slots or 4 channels at the same time, which means the bus goes to all 4 channels at the same time. To know which of the 8 slots to populate for optimal performance, basically, because you don't want to just start sticking them in first come, first serve. You need to know how they divide up, because you want, if you don't have 4 or you don't have 8 memory packages to install, you only have 4, for example, you would want to put 1 in each slot in each channel. So you need to look at the documentation to figure out which ones you need to install first. So basically this is an AMD motherboard. It has 8 slots and supports quad channeling. So you've got 1, 2, 3, 4, 5, 6, 7, 8. And each of these that are lit up has a RAM chip in it. And basically this motherboard has a lot of LED lights on it, so it is what it is. But you could install 2 more RAM packages here if you wanted to. DIMM speeds in megahertz and PC ratings. So PC rating is a measure of bandwidth moving between the module and the CPU. To calculate it, you would multiply the speed of 8 bytes, because DIMM has 8-byte or 64-bit data path. So for DDR4 that runs at 3000 megahertz, has a bandwidth of transfer rate of 3000 times 8, 24,000 megabytes per second. And so that would, you would say, would be, that would be PC for 24,000. So PC tells you the the bandwidth. PC 24,000, and the number 4 tells you that it is DDR4. And so the DDR4 rating is labeled PC4. Error code or error checking in parity, ECC RAM. This is usually, or in the past it's been usually relegated to servers. You can find personal PC motherboards that take ECC RAM, but it's just expensive. Parity, basically older SIM packages used error checking based on an extra bit. So you have 8-bit channels, but if you had that extra 9th bit, you can use that for error handling. So basically what we have here is some DDR4 RAM, 16 gigabyte package. The speed is 2666 megahertz. It's PC4, which means it is DDR4. And so if we multiply, let's see, 8 times 48, 8 carry 4, 52, 2 carry 5, 48, 53, 16, 17, 18, 19, 20, 21. So yeah, so if we multiply the 8 bits times 2666 as we were instructed to. Back here, we got 8 bits times the bandwidth, or times the speed rather, because these are 64-bit, or pardon me, 64-bit or 8-byte modules. We multiply 8 times that number, that will give us the throughput or the bandwidth. So basically this is 21,300 megabits per second. Same thing down here, we take 8 and we multiply it by 2133, and that will give us 17,000 or thereabouts. It's rounded to 17,000, but it's also DDR4, and it's a 32-bit, 32 gigabyte module rather than a 16 like that is. Buffered and registered. Buffer basically is a little faster because it has a buffer to hold data, and so it holds data until it has a full buffer, and then it sends it all in one big burst. Essentially, it can increase memory performance. Okay, buffered and registered DIMMs. Buffers and registers hold data and amplify signal before data is written. This can increase the memory performance of a server. What they're saying basically is you can have a buffer, which is extra space to hold information. So the buffer fills up as RAM or as information is being processed. It gets placed into a buffer. And that buffer is like a little temporary storage facility. And as soon as the buffer is filled, then it moves out and goes wherever it is supposed to go, whether that's the processor or whatever. It sends it out in spurts rather than as it comes in. And so it can send out big chunks of data, and it will usually run a little fast. Registers are also kind of the same thing. Basically, it's an organizational tool within the memory, and so anytime you have a registered or buffered RAM, it's going to be a little bit faster. Column access strobe latency is a way of measuring access timing. Refers to the number of clock cycles it takes to write or read a column or a row of data from a memory module. Lower value is better because that means it does it faster. You have low latency. If you've ever played a video game online, you know that latency is a bad thing, and the less latency you have, the better. Memory module adds provide CAS latency value with a series of timing numbers. Basically, it's going to look something like that. So when you're looking at purchasing RAM, lower latency is better. Today's laptops use DDR4, 3L, 3, DDR2, and SODIMM occasionally, but that's a really old laptop. You probably wouldn't find one on the market that uses SODIMM. Types of memory used in laptops. Today's laptops use DDR4, 3L, 3, and DDR2 SODIMM, which is small form factor or small outline DIMM. Basically, these are little chips. They're about half the size of a regular RAM chip. Only use the type of memory that the laptop is designed to support, because frankly, if you don't, it won't work. The number of pins and the position of the notches on the SODIMM keep you from inserting it the wrong way or into the wrong module. So basically, for the most part, these are not interchangeable, and the number of slots are what keep you from making a mistake. It's not a bad idea, just real quickly, to take one of the old RAM chips with you when you go to the store to buy this stuff. If you're buying it, in person, it's not a bad idea to take one of the chips with you because the slots are going to be the same, and it's a good way to compare. To upgrade memory, basically, you're just adding more RAM. And it will solve a lot of problems. Slow performance, applications that refuse to load, or it spends a lot of time grinding at the hard drive because it's using the hard drive as a exchange memory. You have system instabilities, you're getting blue screen of death, those kind of issues, or you get a message from Windows that says insufficient memory. You'll get those a lot of times when you have too many applications open, or you're trying to work on a file that's too big or something like that. Questions to ask: how much do you need? I can tell you all of it. Doesn't matter. All that you can install is how much you need. Now, that's probably not true, but it is, in a way, it's true. There's no sense in not having everything that you have available to you. Find out how much is installed, how much can be installed, and see then if it's worth it to upgrade, or sometimes it might be better just to buy a new system. What kind of memory? Is it DDR2, 3, 4? What? Is it SODIMM or DIMM? Is this a laptop or a desktop? what kind of modules fit in the board, how many slots do I have, and what kind of registers do they have. Do I have to have ECC? Do I have to have buffered or registered RAM? How do I select and purchase the right upgrades? A good idea is to verify, verify, verify. Read the documentation, make absolutely sure, because the last thing you want to do, especially if you're doing this for somebody else, is to get the wrong stuff and then have to get a refund, send it back. And a lot of places, from memory, they will not take it back once you open the package. So if you've opened the package, you own it. And then physically installing, it's very simple. You just turn off the PC, unplug the power, punch the power switch button once or twice to drain the capacitors, open the case, find the slots, verify that you're putting in the chip the right way, that the notches all match up. Gently but firmly push it down into the slot, and the two little corner clips should automatically close. And then kind of give them a little push to make sure they fit all the way into the sockets at the edges of the chips, and you've installed RAM. Once again, how much memory do I need? How much will it support? That's how much you need. Limitations, they are only from the motherboard, the processor, and the operating system. Those are your three sources of limitations. You want to get everything that your least powerful component of these three will support. Windows 10 or 8 or 7 require at least a gigabyte of RAM for 32-bit, and for 64-bit you need 2 gigabytes of RAM. For 64-bit Windows installation, 10 Pro can support up to 2 terabytes of memory. That's RAM, that's not a hard drive. That is 2 terabytes, of RAM. That's a lot of RAM. Windows 8 can support 512 gigs. Windows 7 Pro can support 192 gigs. Any 32-bit Windows, which no one should be using at this point, but if you find an old PC somewhere, its absolute maximum is 4 gigabytes of memory. So that's all it will ever do. 32 bits can't go any further than that. What type's already installed? As I said a while ago, it's a good idea to take a slot of RAM, to empty one of the slots and take the chip with you if you're going to purchase the memory yourself. But you want to open the case and look. This is the thing that so many people, they go to the store before they ever open the case. Open the case and look at the slots. How many slots do you have? How many are filled? Review the module imprint. That means look at the notches in the bottom of the chip to make sure they'll fit. Look at the motherboard documentation. Look at the online for that manufacturer and see if you can figure out that particular model of you need to know the model of your motherboard, and you need to go and research that on the internet and find out how much memory it will support. Read the documentation. See if the board supports dual, triple, or quad channels. And then if you still haven't, once again, take the motherboard and the old memory modules to the parts store for confirmation. That's probably the best way to do it. You'll never be wrong if you do that. Basically, these are the notches I was talking about, and they will fit. Some things, the sockets will fit just one way, so you don't have to worry about trying to put them in wrong. Look for the manufacturer's model number, and somewhere on this board, okay, so we know it's an Asus board, and the model, it's Prime 2370-P. So if you go online and search Prime 2370-Z370-P, Asus, if you put that into Google, you're going to get all the specifications and all the components that are going to work with that board. And then you can just go to whatever manufacturer or whatever supply place you're using and order or purchase whatever you need. How many and what kind of modules can fit on my motherboard? DIMMs can be installed as single modules. Now, you won't be able to do multiple channeling, but if you just want to put one chip in, if that's all you got, that's all you got. And it doesn't hurt anything. To support dual channeling, you got to have matched chips. And you have to have 2 of them, or 3 for triple channeling, or 4 for quad channeling. For one DIMM, if you're going to install one DIMM by itself, place it in the blue slot farthest from the processor. And when they say blue, they may be different. What you're going to find is that on the motherboard, for each channel, the slots in each group are the same color. So you'll have a blue and a white, maybe, and then the next group you'll have a blue and a white, and the next group. Each of the blue ones are part of a channel, each of the white ones are part of a channel. So essentially that's how you can tell. Motherboard using DDR3. Basically, I'll let you read this part. Serial presence detect. Any memory that you're going to buy today will have that. Basically, it declares the module size, chip speed, voltage, etc. to the BIOS. So when you go and look at the BIOS, your BIOS will tell you what size memory module, what speed it is, whether it's DDR2, DDR3, if it's 21,000, if it's 24,000, whatever speed it is. The voltage, it should be 3.5 volts. If it's not, then something odd's going on. But regardless, it'll tell you the voltage and then the data path. If it's 32-bit, if it's 64-bit, that's the width of the data path. All that information should be in the BIOS. All modern memory supports that now. Back in the day, it just said 24 gigs of RAM or 24 megs of RAM or whatever. Okay, there are the chips. There are 4 slots. You got a black one and 3 blue ones. And so basically, if you're going to install a single chip, you might put it in this black one here and leave the blue ones empty, and that would be fine. Actually, you could probably put it in any one of those slots and it would work, but there are some subtle differences that you might want to take into consideration. Compromises: if the exact match is unavailable, mixing unbuffered and buffered will not work. If it's buffered memory, all the chips have to be buffered or registered or it won't work. You can mix and match manufacturers, but it's not a good idea because there are some subtle differences in the architecture of the chip. If mixing memory speeds, it'll work, but what's going to happen is all the modules perform at the slowest speed. So you don't get any boost at all. If you've got a couple of really expensive chips of RAM and then a really cheap one that's really slow, don't put the slow one in because it's going to slow your expensive one down. So you want to use the websites to research your purchases, and most of them will have a configurator. That's a website utility that allows you to pick or allows you to choose different components, and then it'll tell you if those things are compatible and how they'll work. For example, Crucial does exactly that. You can kind of use these little drop-down boxes to figure out exactly what you need, and then they'll give you the exact model number that you need. When you're installing anything into a computer, this is good general rules for any kind of opening of the case. Always use an ESD strap, that's a wrist strap, grounded to the case. Turn off the power, unplug the cord, press the power button, remove the case. Handle with care, don't touch the copper. Touch the edges of the chip and keep your fingers off the pins. Don't touch the edge connectors or the pins, don't stack them. Look at the notches on one side and then look at the notches, the corresponding notches in the memory slot, and figure out how it's supposed to go in and go from there. Pull out the supporting arms. Those are the little clips that clip into the sides. Use notches to guide your way in. Insert the DIMM straight down. Don't come in at an angle. Unless you're doing a laptop, then you're going to have to come in at an angle. Once the DIMM is fully inserted, you push down a little bit, not hard, but a little bit, then the supporting clips will pop back into place. When the PC powers up, it will go in and count how much memory is present. And a lot of PCs will tell you, like a Dell, for example, the startup screen on a Dell, if you've changed the memory or taken some memory out or added some memory in, you'll get this message that say memory amount has changed. But if nothing else, you can go into the BIOS and you can make sure that the new value of memory is in there as it should be. These are the clips, and when you push down this chip into the socket, these should pop up automatically and clip into those little edge sockets. So you're using your thumbs, you're pushing straight down, and then these pop into place and they lock so that your memory doesn't get away. Upgrading in the laptop is similar. Make sure you're not voiding the warranty. Search for the best buy on suitable or authorized parts. This is a good idea to go back to the manufacturer. Decide how much to upgrade, purchase it, and install it. That's pretty simple. Make sure that it matches the type of memory that the laptop has or supports. Most important part of the motherboard, this is the summary. Most important part on the motherboard is the CPU. Processors are rated for their speed, lithography, that's how they're printed, the socket and the chipset they use, and then whether they have multiple cores, multiple threads, etc. Memory cache, you have L1 cache, L2 cache, and even L3 cache. Basically, this is a buffer space for processing information. Once it comes out of the processor, it goes into the cache, it fills up the cache, and then it all shoots out to go to wherever it's going throughout the computer, all in one big blob rather than little bits at a time. Virtualization, the processor has to support it and the motherboard has to support it. Integrated graphics, if you don't have a graphics card, then essentially you're going to have integrated graphics where your processor does part of the job for processing, and basically it slows down the processor. So that's the thing you want to consider when you're upgrading a processor is, do you have a video card of some kind, or are you going to use an onboard graphics card? Overclocking, if you want to turn your clock speed up. On AMD, they make it really easy to do that. On Intel, not so much. There are some pros and cons. The pro, of course, is you're increasing the speed of your chip past what it's expected. If you bought a 2.3 gigahertz chip and you overclock it to 3, then hey, you've got a lot faster chip. Now the downside of that is it gets a lot hotter. These chips are basically, especially with AMD, what they do is they make a chip and they put it on a system and they do some benchmark testing, and whatever testing that chip supports, that's what they call it. Now with AMD, they don't do a really good job of making it absolutely locked down. They don't stress the chip. They just say, okay, this is what it is. This is why with an AMD, you never know really what speed you're going to get. You can overclock an AMD really easily, but the problem is it gets hot and burns up, and that's a problem. The cores of a processor, 2 arithmetic logic units, basically. Current families for Intel are Core, Pentium, Atom, and Celeron. For AMD, they're Ryzen, Ryzen Pro, Threadrippers, A series, and FX. Make sure that your motherboard supports the exact chip that you're buying, otherwise you're going to be going back and buying something else. Because motherboards and chips are not interchangeable. One motherboard's going to support one family or one type of chip, and that's all it's going to support. So make sure, and AMD and Intel are not generally interchangeable. If you buy an AMD chip, you're going to need to get an AMD motherboard, etc. More summary: when installing a processor, make sure you follow the directions. Make sure that you always use a static strap. Always apply thermal compound unless you look at the bottom of the fan and there's already a little gray square there. If there is, that means the thermal compound's already there. Don't apply it until you check. If you don't see, if you just see bare copper or bare metal there, then squeeze out one little dollop of the thermal compound about the size of a small English pea, and that will do what you need to do. Dynamic RAM is stored in DIMMs. DIMMs for laptops. Current type of DIMMs are DDR4, has 288 pins. That you need to know, by the way. DDR3 and 2 have 240 pins. Matching DIMMs work together as dual, triple, or quad channels. They need to match, and it's a good idea even to use the same manufacturer. DIMM speeds are measured in megahertz or PC rating. So it'll give you the megahertz. You multiply that by 8, which is the 8-bit or 64-byte bus width, to get the PC rating. And then memory controller can check memory for errors. ECC is error correction, and so if you have errors as the data is going by, ECC RAM will check it and can help fix some of those errors. And then finally, buffers and registers. If you're using buffered and registered RAM, it's not interchangeable with non-buffered, non-registered. CAS latency measures access time to memory. Lower is better. Laptops also use DDR4, 3L3, and DDR2 SO-DIMMs, which means small output or small outline. When upgrading memory, you've got to use the same type and size and speed that the motherboard supports. When upgrading components, including memory, use components that are the same brand as the laptop. That's a good idea. Or use components that are recommended. If you're using non-OEM parts, make sure that they are certified or recommended by that manufacturer. Also remember, if you're using RAM with different speeds, then it's interchangeable. You can mix that, but the RAM will only operate at the speed of the slowest chip. And that's an important thing to remember. So don't spend a lot of money on an expensive single chip of RAM if you've already got what you've got in there is slow, because it's going to slow down that expensive fast chip. Okay, so I hope that was helpful. Didn't go really deep into it, nor do I plan to. These lectures are just kind of hitting the high points. So basically, when you come into class, we're going to do the hands-on portion. You can work at your own pace. I don't know if I've probably mentioned this already several times, but you work at your own speed on these labs. Once you have them done, then you can move on to the next lab, and we'll go on from there. There are only 10 labs hands-on, so basically that's 10 weeks. Plus, we'll have, of course, a week out for spring break, and then we'll have I imagine we'll have at least one more holiday in there. So that will give us about 6 weeks of time where we're just going to be working basically on in-class exercises. So if you have any questions, the best way to contact me is via the Canvas inbox, and make sure that you're keeping an eye on the announcements as they come in class. Also, make sure you're keeping an eye on your grades. Do not get behind on these chapter tests. Remember that you can retake them. If you mess up a chapter quiz, you can retake it as many times as you need until the due date passes. At that point, then the chapter quiz will expire and you will not be able to turn in anything else. So you have until the due date expires. You're basically working at your own pace. This is a self-directed class for the most part. I won't do a whole lot of lecture unless you have questions. Now, if you have questions, I will go into detail with you. But until you have questions, I'm going to assume everybody's doing well. So let me know. Communication is important. In the meantime, I hope you have a good week, and let me know what's going on. Thanks.